Look up at the night sky. What do you see? Stars, galaxies. A tiny patch of the Hubble ultra-deep field filled with distant galaxies. A vast, dark expanse that seems to go on forever. For millennia we believed this was it. This was everything. Our universe. The one and only. But what if that view, as grand as it is just a single grain of sand on an infinite cosmic beach? What if our entire universe, with its billions of galaxies and countless stars, is just one bubble in a vast, churning ocean of other universes? This idea isn't just science fiction, it's a frontier of modern physics, a mind-bending possibility that challenges everything we thought we knew about our place in the cosmos. It asks the ultimate question: are we alone, not just on our planet, but in our entire reality? The journey to this question begins with a sense of wonder. It's the same wonder that drove our ancestors to chart the stars and to understand the seasons. Today, that wonder has led us to the very edge of our observable universe. We can see light that has traveled for over 13 billion years to reach us. But what lies beyond that edge? Is it just more of the same, stretching on infinitely, or could there be something else entirely? Imagine our cosmos as a single, magnificent book. Its pages contain the stories of every star, every planet, every life form that has ever existed within it. But the multiverse theory suggests there might be an entire library. An infinite library of books, each with its own unique story, its own physical laws, its own version of reality. Some might be similar to ours, while others could be so alien, so bizarre that they would be beyond our wildest comprehension. So, let's embark on a voyage. A journey not just across space and time, but across realities. We will use the tools of science and the power of imagination to explore this grand idea. We'll look at the theories that suggest these other worlds might exist, from vibrating strings to cosmic bubbles. We'll meet the thinkers who are daring to map this unseen territory. Prepare to have your perspective shifted. The universe you know might be just the beginning. The cosmos could be far larger, far stranger, and far more magnificent than you have ever dared to imagine. Let's open the door to the multiverse. So, what exactly is the multiverse? Let's break it down. The idea is simple at its core. The word multiverse is a combination of multiple universe. It proposes that our universe, everything we can see, touch, measure, is not the only one. Think of it like an archipelago of islands. Our universe is one island. Other islands float nearby. Other universes exist, each separate and distinct. Some might be just over the horizon. Others are unimaginably far away, perhaps forever beyond our reach. This isn't one single idea. The multiverse is a category of scientific proposals. One version, space is infinite. If it goes on forever, statistics say particle arrangements must repeat. Far away, beyond what we can see, there could be another Earth. Another you, a life almost identical to this one. Another version. You chose a different breakfast this morning. Another, dinosaurs never went extinct. Infinite space means infinite possibilities, repeated. Another model, the bubble universe theory. New universes are constantly being born. Our universe is one bubble that inflated in a cosmic foam. Like bubbles in boiling water, new universes pop into existence. Each expands and evolves with its own physical laws. Some are like ours, forming stars and life. Others are duds, collapsing instantly, or expanding so fast no structures form. Our universe got the recipe right. Key takeaway, our universe might not be the whole show. The laws we hold dear, gravity, electromagnetism, speed of light, might be local bylaws. In another universe, gravity might be stronger, or light might travel at a different speed. The very fabric of reality could be different. The multiverse turns our everything into something within a grander landscape. It's a profound shift, like realizing Earth is not the center of the solar system. How could such a wild idea like the multiverse even be possible? One of the most compelling, though still unproven, paths to the multiverse comes from something called string theory. For decades, physicists have been on a quest for a theory of everything. A single, elegant framework that could unite the two great pillars of modern physics: general relativity, which describes the universe on a grand scale, stars, galaxies, and quantum mechanics, which describes the universe on a tiny subatomic scale. String theory is one of the leading candidates for this ultimate theory, and it has a fascinating consequence. String theory proposes that the fundamental building blocks of reality are not point-like particles like electrons, quarks. Instead, they are unimaginably small, one-dimensional vibrating strings of energy. Think of a guitar string. Depending on how you pluck it, it can vibrate at different frequencies to create different musical notes. According to string theory, the elementary particles we see are just different notes played on these fundamental cosmic strings. One vibrational pattern appears to us as an electron, another appears as a photon, All the richness and complexity of the universe emerges from the symphony of these vibrating strings. Here is where it gets interesting and connects to the multiverse. For the mathematics of string theory to work, it requires more dimensions of space than the three we are familiar with: length, width, height. In fact, most versions of the theory require at least 10 spatial dimensions. So where are these extra dimensions? The theory suggests they are curled up, compacted down to a size so infinitesimally small that we cannot perceive them. Imagine a garden hose. From far away, it looks like a one-dimensional line, but for an ant walking on its surface, it has a second dimension, the circumference you can walk around. This is the gateway to the multiverse. String theory doesn't just predict one way for these extra dimensions to be curled up, it predicts a staggering number of possibilities. Perhaps 10 circumflex 500. Each of these different ways of compacting the extra dimensions would result in a universe with its own unique set of physical laws. Our universe, with its specific laws of gravity, particle masses, is just one of these countless possible solutions. The collection of all these possible universes, each born from a different configuration of the extra dimensions, is known as the string theory landscape. It's a multiverse woven from the very threads of reality. Let's dive deeper into one of the most cinematic visions of the multiverse, the idea of bubble universes. This concept comes from a theory called eternal inflation. To understand it, we have to go back to the very beginning of our own universe. The Big Bang theory tells us that our universe began in an incredibly hot, dense state and has been expanding ever since. For a brief fraction of a second after the Big Bang, the universe underwent a period of mind-bogglingly rapid expansion known as cosmic inflation. It grew from smaller than an atom to larger than a galaxy in the blink of an eye. The theory of eternal inflation takes this one step further. It suggests that this inflationary process is not something that happened just once, and it might be happening all the time, forever. Think of the background space, the metaverse, as a vast ocean of energetic fuel that is perpetually inflating. But here and there, in random spots, this inflation can stop. When a region of this inflating space slows down and releases its energy, a bubble forms. That bubble is a new universe. A Big Bang happens inside that bubble, creating matter and energy. The bubble universe then begins to expand and evolve on its own. Our universe would be just one of these bubbles. The parent space outside our bubble is still inflating, constantly spawning other bubbles and other universes. Each of those bubbles could have its own Big Bang. It creates a fractal-like, never-ending cosmic structure, a foam of universes, each an isolated pocket of space-time, likely forever out of contact with the others. They could be bumping into each other theoretically, but for the most part each bubble is its own self-contained cosmos. This picture paints a dynamic, living cosmos where creation isn't a one-time event, but an ongoing, eternal process. Each bubble could be different. The fundamental constants and laws inside a new bubble might be determined randomly as it cools down from its energetic birth. One bubble might have stronger gravity, another might have only 2 dimensions of space, another might have different fundamental particles altogether. Most of these universes would be sterile, unable to support complexity or life. But in a cosmic foam of infinite bubbles, it's inevitable that some, like ours, would have the right combination of laws for stars, planets, perhaps even us to exist. This all sounds like a fantastic story, but is it science or is it just philosophy? The ultimate test of any scientific theory is whether it can be tested. A multiverse that exists completely separate from our own, with no possibility of interaction, would remain forever in the realm of speculation. So, are there any ways we could find evidence for these other universes? American physicists and cosmologists are creatively tackling this very question, pushing the boundaries of observation and theory to look for clues. The search is on, and it's one of the most exciting frontiers in science. One tantalizing possibility involves looking for bruises in our own universe. If our bubble universe is just one among many in a cosmic foam, it's possible that it might have collided with another bubble in the distant past. Such a cosmic fender bender would have been a cataclysmic event, and it might have left a subtle, lasting imprint on our cosmos. This imprint could appear as a strange pattern in the cosmic microwave background, the faint afterglow of our own Big Bang. Scientists are meticulously scanning maps of this radiation, looking for anomalous cold spots, looking for anomalous hot spots that could be the signature of an ancient cosmic collision. Another avenue of investigation comes from gravity. Particles and light might be trapped within our own universe's dimensions. Some theories suggest that gravity might not be. Gravity could be weaker than the other fundamental forces because its influence leaks out into these other dimensions or other universes. Experiments at particle accelerators like the Large Hadron Collider are, in a way, searching for the multiverse. By smashing particles together at incredible energies, physicists hope to see if any energy or momentum disappears from the collision. If it does, it might be escaping into an extra dimension, a telltale sign that our three-dimensional universe is not all there is. Furthermore, precision measurements of our own universe's fundamental constants could offer clues. Why does our universe have the specific amount of dark energy that it does? This mysterious force is causing the expansion of our universe to accelerate. Its measured value is incredibly small, a fact that has long baffled physicists. Multiverse theory offers a potential explanation. In a vast landscape of universes, there will be all sorts of values for dark energy. Most would be inhospitable. We simply find ourselves in one of the rare universes where the value is just right to allow for galaxies, stars to form. Finding that our constants are finely tuned for life could be considered circumstantial evidence for a multiverse. The story of the multiverse is not just a story of ideas but of the people who dared to think them. In the United States, a hub of theoretical physics, brilliant minds have been wrestling with these cosmic possibilities for decades. Their work has shaped our understanding and pushed the boundaries of what we consider possible. People like Alan Guth, a physicist at MIT, revolutionized cosmology in the 1980s with his theory of cosmic inflation. While he wasn't initially thinking about a multiverse, his work laid the essential groundwork for it. Guth's inflation theory solved several major puzzles about our own universe, like why it's so uniform and why it's flat. But he and other physicists like Andre Linde at Stanford University soon realized a stunning implication of the theory. The mechanism that started inflation in our universe was likely to be eternal, leading directly to the bubble universe model. Linde became a major champion of eternal inflation and the multiverse hypothesis, arguing it isn't a strange bug but an unavoidable feature. He paints a picture of a cosmic tree with universes branching off eternally. Another giant in this field is Leonard Susskind, also at Stanford University. He is widely regarded as one of the fathers of string theory and a key proponent of the string theory landscape idea. Susskind famously engaged in a black hole war of ideas with Stephen Hawking, and his work on information and black holes led him to embrace the multiverse. He argues the landscape of 10 to the 500 possible universes predicted by string theory is not a flaw, but a stunning prediction. It provides a natural explanation for the fine-tuning of our own cosmos, a concept he calls cosmic censorship. We only see a universe that works because the others are sterile. These physicists and many others like them, including Brian Greene at Columbia University, approach the subject with a mix of rigorous mathematics and bold imagination. They are not just idly speculating, they are building complex mathematical models and proposing potential observational tests. Their work represents the cutting edge of human curiosity. They are the cartographers of the cosmos, drawing maps that extend beyond the shores of our own familiar universe into the vast uncharted waters of the multiverse. Their courage to ask what if is what drives science forward. Let's pause for a moment and truly absorb the implications. If the multiverse is real, what does it mean? The possibilities are as varied as they are staggering. In one category of multiverse, born from infinite space, there are other versions of you, an infinite number of them. Imagine a universe identical to ours, but where you decided to pursue a different career. Another where you married your childhood sweetheart. Another where you took that trip you always dreamed of. More somber versions where personal tragedies were narrowly averted, or where they tragically were not. Every choice, every random event branches off into a different reality, playing out in some distant corner of an infinite cosmos. Then there are universes with entirely different physical laws. Picture a universe with 2 dimensions of time. What would life be like there? Or a universe with no electromagnetism, a world cloaked in perpetual darkness, no light to see by. Could life evolve there, perhaps based on sound or touch alone? Imagine gravity as a repulsive force pushing everything apart, a cosmos where no stars or galaxies could form, just a thin, cold mist of lonely particles. The multiverse concept forces us to abandon our cosmic provincialism. We tend to think our way of being is the only way. Our laws of physics seem perfect, but maybe just a local fluke, a lucky draw in a cosmic lottery. This perspective is called the anthropic principle. We find ourselves in a finely tuned universe because if it weren't, we wouldn't be here to observe it. It's like a fish wondering why its pond has water. If it didn't, there would be no fish to ask the question. This symphony of possibilities is humbling and inspiring. It suggests existence is far grander and more creative than we ever conceived. Our universe, beautiful spiral galaxies, fiery stars, its delicate blue planet, these may be one masterpiece in an infinite gallery of cosmic art. Some pieces are chaotic messes, some are starkly minimalist, others hold a beauty so alien we couldn't recognize it. Our universe is special to us because it's our home, but knowing it's not the only home is perhaps the most profound realization of all. Let's step aboard the spaceship of the imagination for a final tour of this grand idea. Our journey has taken us from the familiar night sky to the vibrating heart of reality itself. We've seen how theories born from the desire to understand our own universe have unexpectedly pointed to the existence of others. String theory with its hidden dimensions, cosmic inflation with its eternal engine of creation. They paint a picture of a cosmos not as a single lonely entity but as a thriving, bubbling, endlessly creative multiverse. We've seen how this isn't just an armchair fantasy. We are actively searching for the evidence. We scan the ancient light of the Big Bang for bruises from cosmic collisions. We smash particles together with tremendous force, hoping to catch a glimpse of energy slipping into another dimension. The quest is difficult. The signals, if they exist, are faint and buried in cosmic noise. But the search itself is a testament to the human spirit. We are not content with the answers we have. We are always pushing, always exploring, always reaching for the next horizon, even if that horizon is another universe. The multiverse challenges us to think differently about ourselves. If there are countless other universes, some with other versions of us, does that diminish our own lives? I don't think so. I think it does the opposite. It makes this life, this unique sequence of events and choices that you are experiencing right now, all the more precious. Out of an infinite sea of possibilities, this is your reality. This is your moment. It's a unique performance in the grand cosmic theater, and it's happening right now. The awareness of those other potential realities should inspire us to make this one count. This journey also reframes our search for extraterrestrial life. We scan the stars in our galaxy for signs of other civilizations, but what if the ultimate aliens are not on other planets but in other universes? Beings that evolved under completely different physical laws, made of forms of matter we can't even conceive of. The multiverse suggests that the universe of possibilities is infinitely richer than just the possibilities within our own universe. The cosmos may be teeming with existence in ways we have not yet dreamed of. The stage for life might not be a single theater but an infinite chain of them. So we return to where we began, under the vast canopy of the night sky. But our perspective has changed. The stars no longer seem like distant, lonely points of light in a solitary void. They now appear as our local neighborhood in a potentially infinite cosmic city. Our entire observable universe, all 93 billion light-years of it, might be just a single room in a mansion with an uncountable number of rooms. This thought is not meant to make us feel small or insignificant. On the contrary, it should fill us with a profound sense of awe and wonder. The quest to understand the multiverse is the next great chapter in the human story of cosmic discovery. First, we thought the Earth was the center of everything. Then we learned we were on a planet orbiting a star. Then we learned our star was just one of hundreds of billions in the Milky Way galaxy. Then we learned our galaxy was just one of trillions in the observable universe. Each step was a humbling demotion, but also a glorious expansion of our understanding. The multiverse is the logical next step in this journey of cosmic perspective. It is the ultimate Copernican revolution. We may never know for sure. We may never receive a postcard from a parallel universe. We may never shake hands with an alternate version of ourselves. The evidence may remain forever tantalizingly out of reach. But that does not diminish the power of the idea. It stretches our minds, it fuels our imagination, it encourages us to ask the biggest questions we can think of. The pursuit of these questions, the rigorous application of science to the grandest of scales, is one of the noblest things we do. It is an expression of our deepest curiosity, so keep looking up, keep wondering. The universe is under no obligation to be simple or to make sense to us. It is what it is. And it might be vastly more strange, more beautiful, and more infinite than we can currently comprehend. We are stardust. We are a way for the cosmos to know itself. And as we contemplate the multiverse, we are perhaps a way for our universe to wonder about its siblings. Our place is not just in the universe, our place is in the grand, unfolding mystery of everything, and the adventure has just begun.